Hey, it's W5HRO. Here's the latest update. This is no longer going to be a temp video. This is going to be the replacement for the last few temp videos I put on there. Because I'm waiting on parts again. I got to get a couple more resistors in. They're not going to be shipped until about the 15th now. So unfortunately, another couple week delay until I can get this thing finished up. Uh, Basically, it's I've got everything hooked up. And but what I have to do, what I'm waiting on is I'm putting these authentic Dale resistors in place of these ones that are I put in here already. These are those cheap Chinese ones, and since I had these two down here blow up on me, or that one I had what I had was I had one of those Chinese 8Ks. I had a single one in there, and the thing opened up on me, so I had to get it to 7.5K with two 15K Dales in parallel. And what I'm going to do is, these two here do get pretty hot. But what I figured I can do is you can get to, I found some little small like square heat sinks, rectangle heat sinks. You can get different sizes. And they're very thin. They're only like, like maybe they might, the thing I'm trying to do is see the bottom of this thing. Well, I'm trying to keep, the reason I've gone this route and the reason I use these size capacitors and have done everything this way with the resistors and the way I've done it is because I'm trying to keep all the components from protruding out past this bottom of this rack, right? Because when I slide it in the actual homebrew transmitter cabinet, if anything's sticking, it's going to hit the front panel on the speech amp driver deck, and I don't want to scratch up that panel. I'd have to kind of maneuver it, and if I forget, so I always try to keep this stuff so it doesn't go past it, which so far it pretty well is. There might be one thing that might be just a millimeter or something past it, but it's pretty well, down below it. So that's what I always try to do with these racks. I keep all the components on the bottom side underneath like that, and they've got to be the right size so it all fits and they don't stick out. So, but what I can do is I can find these little small heat sinks, and I've already found several different kinds. I can order one, and they're very thin. I mean, from top to bottom. And I figured what I could do is to improve the power dissipation of these two resistors here. They're going to probably be fine like they are. They're just going to stay hot. But what I can do is I can get some of that little expensive heat sink compound, that stuff they call silver something. What do they call it? It's kind of like a silver gray, and it dries really hard like glue. And if you ever have to remove the component, you have to like scrape it off, and it takes forever. I thought what I could do is I could smear a little bit of that on top of these resistors and just stick one of those heat sinks on there, and let it harden. And then when the thing's tipped up right, it won't ever fall off, and since it's hard like glue, it'll just stay there. So I'll probably add that to those two resistors before it's over in the end. And I might even put a big one across these here. I might do it in both places just for extra power dissipation, extra heat, dissipation. But right now what I have is everything's hooked up with the rest of the way via clip leads, and I've been checking the output of this thing, and look at this. And what I've done is I've got my 17.5, this resistor, when I bought the resistor in for my RF deck, I added the 17.5K grid link resistors, because what I need with the bias voltage for Class C, it's like what, minus 110 volt or minus 210 volts or something. It's plus or minus a couple volts. And then with the 17.5K, it comes out to like the 12 mils of grid current. So when I bought these non-inductive 17.5K resistors years ago, I bought 3 of them, so I still have 2 of them left. And I was actually going to use this one and the other one at the input. I was going to modify that SB10 sideband adapter that this thing's eventually going to be able to be switched to via the one relay. And I was going to put these for the loads inside there on the input so it matches what's in the RF deck and do it that way, because you can't run this thing in the 50 ohms. That would be too low of an impedance. It would just kill the output. So 17.5K will work. It's high enough, you'll still get plenty of power going across them. So basically I did that, and I'm on the 200 watt scale, and this meter will not read right because it's a 50 ohm meter calibrated for 50 ohms, and I'm going to dig around here later today. I know I have a 3 amp RF ammeter with the built-in thermocouple, but I need like a 1 amp. I need something a little smaller that's going to show something, and I could take this this resistor and I could solder it from the one terminal down the ground, and I could just, you know, drive that meter, and I could just calculate, you know, what the wattage is, you know, from the voltage and everything and the current. So I know what current is what power output, and I could do it that way to get it more accurate. But I'm probably just gonna, when I get this thing all, the new resistors in here, get everything buttoned up, I'm gonna slide it in the homebrew transmitter cabinet. And I'm just gonna plug it to the 4400. And I'm just gonna power it up, and I'll set everything that way, instead of trying to do it here with the RF amp meter. But I might, if I can find a smaller one. I know I have a 3 amp one somewhere, but that's probably gonna be too big. What's 25 watts? Because what'll happen is this exciter, you know, if the 6000 tube was at 400 volts and the screen is at 200 volts, the max power output that would be about 28 watts. But since it's running lower than that, it's going to be, you know, it's going to be like maybe 25 watts max. But we don't need that much power. The 4400 only takes about 5 watts of drive. However, going through this, since it's a high Z output going through a short piece of coax to the RF deck, then it's going to load it down a little bit. So, you know, it's probably, the output's much higher Z than 1820K, because the T368 exciter RF deck, they used a 20K grid leak, but since my tube is a 4400 CG, it requires a few more mils of grid drive than the standard 4400A does, so that's why I'm using a 17.5K. 18K, I think it calculated out to 17 point some odd K, and the 17.5K was the closest thing I could find. I looked for 18Ks but years back, but I found these instead. So I just grabbed them. It was close enough. So anyway, here we go. Let me go ahead. What I've done is I'm connecting, everything's powered up, but I'm not connecting the high V to the pass transistors here, or to the bases through the resistors until I, you know, engage this knife switch. I found this in one of my junk boxes, this old Radio Shack knife switch from years ago. So let me go ahead and push this down. Look, boom. See, look, wow. It's showing almost 100 watts. What that means is, you know, I don't know, it's not accurate because it should only be doing about 25 watts max. Right now I've got 200 volts on the screen of that 6000 tube. I don't have the pot connected yet, but you can see it's actually working, and look at the frequency. 38.74, that's where it was the last time. It hasn't moved a bit. This thing is stable. You know, now that I've got 150 volts regulated on there, plus the filaments regulated, that PTO is not going to move. It's going to stay in one place. So I should have a very stable frequency output on my transmitter. That's important, because too many guys, I hate it when you get on there and you listen to a guy, say you tune into a guy that's right dead smack on 3885 or 3880 or something, or 3870, let's say. And the next guy comes on and he's several kcs off to one side. I hate that. Why can't people get their frequency right? That's one thing that's always bugged me about most AMers. They're running the old vintage stuff, but there's ways to make the stuff stable so you're on frequency. I hate it when people are all over the place like that. You know, it's irritating. They have to keep tweaking the receiver dial to tune the next person in. Why can't they all be in one place? That's always kind of like, you know, that's one of the things that's always my little pet peeve. So I like to stay on frequency. And especially on 10 meters where the higher bands, my God, the VFOs the old tube VFOs will drift around so much on the higher bands, especially 10 meters. You have to make sure you're on the right frequency. Otherwise you get some sideband or some slot bucket coming in going, would you get a sensitized radio? You know, I had guys, I remember when I used to run one of my old transmitters, I used to run that old Johnson Valiant on 10 meter AM, and that, oh my God, that thing was a nightmare. That thing used to bounce around. I used to have people coming in complaining, get on frequency, get a sensitized radio. Because people will complain, trust me. So what, but still, I hate that. It's irritating to have, you know, 5 people in a group and they're not all in the same frequency. Why is that? People need to get better at that, you know. I guess some old guys are just set in their ways. I'm set in my ways too, but not that bad. So anyway, it's working. It's definitely working. So I just need to finish everything up, and I'm just waiting on 2 more resistors. These are the 15Ks, and I decided, here's my latest schematic. And what I have is, I have this 5K 2 watt, I'm sorry, 5 mega ohm. This is a 5 meg 2 watt pot that I was gonna put up in the RF deck. And we're gonna go in there in a minute and I'll show you where it's gonna go. But it's gonna be a remote pot. And see, here's the screen. See how I've got it? I'm not sure it's gonna work like this, but I think, if the pot's big enough, it should restrict it to where it should start cutting the voltage down. So I'm going to try this design, and I'm not, like I said, I'm not 100% sure it's going to work correctly or not. I think it probably will. And I figured out too that since I couldn't get, there's another resistor I was going to get for because what I also had done is how I had these two Zeners here for the multiplier that was 280 volts, the 6,000 plates, 380, the multipliers 280 volts. And then I changed the screen one to 200 volts. I used 200 volt Zeners, and I thought, you know what? I'm gonna have to have a different drop-in resistor, and I tried a 25K there, and it dropped it down some, but I was looking online, and that's gonna be the lead time on that. It's gonna be it'll be like another 2-3 weeks before I can get the other resistor. So I decided what I'm gonna do is, I'm just gonna go back and I'm gonna put the other Zeners like I had on the screen before, and I'm gonna, like right here, see? This is like the two 140 volt Zeners, 140 volt Zeners. I'm just gonna go ahead, I'm gonna change those back to 140 volts here so I can use the same drop-in resistor. And then what I'll do is, if this pot will work in the RF deck, this remote pot like I'm gonna do, what I'll do is I will, if it doesn't, when I bring this all the way down, if the power output's too hot or the voltage on the screen is too high, I don't need that much, I'll just add a series resistor from the 1 lead of this pot to where I solder the cable on inside the RF deck. I'll just add the resistor at this point and add one more in series with it between right here and there. See, I'll just put it here. So it's like a series resistor with that 5 meg to get it down so the thing's not too hot. So that's how I'll do that, and that should work fine because, a 5 mega ohm pot with 280 volts on it, there's no power. It's a 5 mega ohm pot. It's going to dissipate what? Nothing. So that's why I have to use a big pot. Otherwise, this thing's going to take like a rheostat, and I don't have room in the RF deck, and I'd have to figure out where to put it and put a rheostat in a pot here, which could happen before it's over. I hope not, but that may be a possibility. But this thing's coming to life. These are those NTE62 transmitters, these horizontal deflection NPNs, and those should hold up. Those are those will handle a lot more much higher voltage than those BUX48As. These will handle like the base emitter voltage is what oh no, I'm thinking, no. The collector voltage with the base open is like 900 volts. The base emitter voltage is like 900 volts with the base at 0 volts. That's like the worst case. But the isolation between the base and the collector is like 2,500 volts on these. The BUX48As were higher current transistors, but the voltage was like way less, and that was my problem. That's why I took out the one, and I took out that one. Though the PNP is what took it out, but still, these will hold up. I'm sure these will hold up, these NTE62s. So anyway, let's also, you see right now is that I have, where is it, this diode here. That how I'm going to do this, I'm going to add the spot switch in here. And by the way, let me go get those spot switches. I don't know if I showed this in one of my last few videos or not, but I did. What happened is I said I was going to add a little bit of Heathkit to the mix because I'm putting the Heathkit meter there and everything. I'm going to add the old Heathkit spot switch. What I realized is the single pole, single throw won't work. So I got online, and sure enough, Switchcraft still makes these switches. This isn't a single pole. This is a double pole, double throw, or double, whatever it is. It's a double pole. Yeah, double pole, double throw, I think. But anyway, but that's what I'm doing, or double pole single throw, but that's what I need because it won't, I can't get this combination unless I have one that had the extra terminals. So I'm just going to use this. It'll still look like Heathkit, even though it's not the one they used in the DX100 transmitters and stuff. but it will work. You can see what I'm doing. So I'm shorting across that diode to keep the negative the grid blocking supply on. See? So this is going to that pin A to that P101 connector that I've removed the wires from. So by the way, if you get on w5hro.com and go to my projects and my homebrew transmitter thread, you'll see that I posted I put together a document, and I've actually listed all the connections for this connector and all the voltages. It's never been available online. Nobody's ever revealed. There's been a few guys that have used these things through the years in their transmitters and stuff, and they've had to figure out all the voltages. The problem is those guys have just done it themselves. There's just been a handful of people through the years that have used one of these things, and nobody's ever conveyed, well, how did they hook it up? What pins, what are the voltages? So that's on my website now, so that'll help people, I'm sure, because I know there's a lot of people like me that come across one of these things and they think, okay, I'll use that someday, but when they go to look at it and they think about it, well, where do I even start? What voltages, what pins? Nobody knows how to figure it out unless you got the manual, and it takes a long time to trace all that crap down, and it's like, okay, it's nice to have somebody already go through and do that, and I wish somebody had done that years ago, but nobody did, so I did. I'm the one who had to do it, so it's on my website now if anybody's interested. But what was I going to say? But I'm going to use this switch, but you can see what I've done is that it's shorted across this blocking diode, so the voltage, the bias voltage is getting there, that negative 55 volts. So when you ground that, but however, see, when you ground the top of this diode, see how my spot switch is? The idea is I don't want the relay clicking when I'm just spotting the transmitter. So when I push this button, I want it to be electronic keying, which is what this will do. So see, if I come over here and I unground and I short across this diode again down here, if you can see it. And then see, look, if I hit the knife switch, no power. See, you can hear the transformer coming up. Hear it, listen. I'll do it again. Hear it beep, beep. It goes when I hit the knife switch. So see, look. So that keeps the thing from turning on. Actually, if there's no voltage there, it also does the same thing, but floating may be kind of like unstable, like leaving a digital input open on a device or something. You never know what condition it's going to come up, but maybe not. But that 55, I want that 56 volts. What I've got is I've got negative 56 volts going. If it's close enough, 56 volt Zener, that's fine. So that's where I am on this, and it's coming to life. Finally, I've got output, and I'm getting, hey, I'm trying to get more power, and I forgot I got to come over here and reground that grid blocking supply line so the thing will transmit. Because now what the exciter does is it uses grid leak resistors. Do I have a pencil here? Maybe I can explain how this works so people understand what's going on. I need there we go. What it is, let me see if I can find some place to write here, is that what they've done is, say you've got the grid of the tube here, right? Say the 6,000 tube and the multipliers. And what they've got is, they've got like a grid leak resistor here, and there's some other line that goes across here to the other tubes, and then there's another resistor here, right? Well, what they're doing is they have the minus 55 volts here. Excuse me. So what they do is they ground this line to transmit. They just ground it, right? Which in turn forces this thing to grid leak, so it quits blocking, because the PTO, the output of the PTO is always on. It's going to the grid of the multiplier, the first multiplier tube. But since that multiplier tube grid is pulled way down negative like that, it's blocking it and it can't let it go through. That's how these tubes don't draw any current, or the 6,000 tube won't draw current until the, until that line there is grounded. But that's how they're doing it. And I guess the resistor here is just big enough so it doesn't short out the supply. But I'm doing something step better. I'm actually removing that, and I'm removing that line. It's just gone, right? So anyway, what did I do here? Did I do something? Let me look at that schematic again. Yeah, that's correct. Because I'm looking at the thing the wrong way. Because see, when I hit the spot switch, this line here is open, which means there's no load on this anymore, and that's perfect. And that was also why I put the 1 meg resistor in there across that cap, because I thought, you know, it might be better to have a path to ground around that, have a slight load around that diode when this gets broken and there's no connection to it when you spot it or transmit. Then see, when I hit the PTT from the mic button, this relay is going to click and it's basically going to do the same thing. So when I transmit the transmitter, it's going to click the relay and do it. So when I hit the spot button, it's only going to be just electronic spotting, because I don't want to hear that relay. There's no reason when I'm hitting that spot button to hear the relay go click, click, click. I have to do that. That's not necessary. I can just do it the other way. So that's where I am. I think that's all I've got to say about this. I do have the relays. I just haven't, the relays do click. They do click. And also what I want to show is, I want to ground this relay here real quick. I mean that electronic circuit again. I don't mean grounded, I mean short across that diode so it doesn't come up. Let me hook up the voltmeter real quick. I guess I should have got a little bit better prepared before I started this video. So voltage, and what I'm going to do is, what I've done is, I think I mentioned the relay supply that turns the relays on and off. I'm tapped off that supply with a voltage divider to get the voltage way down. And what I'm doing is I'm powering up diodes, or I'm powering up these diodes, you know, coming down here through these pass transistors. So what I'm doing is I want to make sure these diodes, the diodes in these transistors and everything are always forward biased on before the plate, you know, the high voltage comes up. So that's what I'm doing. When the transmitter powers up, everything, all the filaments are going to warm up, everything's going to come up, but there's going to be no high voltage coming from here. This is going to be broken here. The minus 56 volt supply will be there for grid blocking, but the positive supply will be disconnected. Then after everything warms up for about 20 seconds, there's going to be that time delay, then click. This gets connected, but before that happens, I want to keep these diodes forward biased. So what I'm doing is, I just tapped off that supply, and I have these 4 diodes here, which are these 4 diodes there. Let me show you. 1, 2, 3, 4, and I used the heavier 3 amp diode just to be safe in case something was to short out on that. But what it does is, I've got like around 6 some odd volts coming through here. So it's going to go down. There's going to be like about a 0.6 to 0.7 voltage drop across that one. Then there's going to be 1 more drop across the base emitter here, 1 more drop across the base emitter here. Then it should be, you know, out here, you should see whatever's left here at the output of these chokes going to the exciter, right? These RF chokes. So let me clip on the first one. This is the 150 volt one. And you can see I've got 5.9 volts. And what I did was I made sure it was still high enough. I think it drops down to around 4. When both relays are engaged, it drops down to about 4, but it's still keeping the transistors biased on, forward biased all the time. There's just nothing, you know, there's just no high voltage on the base or the collectors. It's low voltage on the base through the emitters. So there's that one, and here's the one for the screen supply. This one's going to read a little higher because I've got the different Zeners, but I'm going to change those Zeners, so it's probably going to come down a little bit. That one's 6.23 volts DC. Here's the one that goes to the multipliers, 5.8. And then here's the one for the 6,002 to 380 volts. That's 5.7 volts, and that's going to be the biggest drop because it's having to go through 2 pass transistors. So it's going through that diode, this transistor, so it's going to be another point some odd drop voltage difference between this string and the other ones. So, but that extra transistor is there for a current amplifier. I think that's in the last permanent video that I'm keeping, but I'm not positive if I discussed that in that last video or not. I know it was in my temporary videos, but I don't know about my last permanent one. But I just wanted to give one permanent video update here before I continue, because I just got these resistors in yesterday afternoon. So I was going to probably add these today, and I'm waiting for well, the other problem is the other two aren't going to be here until, they're not going to ship until like the 15th, I think the 12th or the 15th. So I've got another week or two to wait. Probably 2 more weeks before I actually get those in. That sucks, but what can I do? But there's one more thing I want to go over. I want to go inside the shack and show you one more thing. So let me stop the video and let me go in there and start it up again. Hey, it's W5HRO. Gonna finish the video now. Let me, I've had the online receiver on 38, where are these guys? 38, 85. These guys are on every morning. There's a guy up in Redding that has a receiver. The one down there at, up there at Point Reeves has been offline ever since the virus started out here. So this other guy has this one up here in this part of California. So these are the guys I'm gonna be hearing when I get my inverted L up and everything. But what I wanted to show you is that I did order the new meter to replace this guy. I've ordered the same Simpson type of meter. It's going to be a 0 to 200 milliamp, because what I'm trying to do is, this is like a really old-timey meter, and it really doesn't match the appearance of the rest of the transmitter. This one's always bugged me. So I'm going to replace this one with one of the new Simpsons, and it's going to be, I ordered a thing like 2 or 3 weeks ago, so it's going to be shipped probably, I think it's going to be shipped next week. I think it was due to ship on the 7th or the 8th or something, September 7th or 8th. So I should have that one in soon. But what I'm doing is I'm changing out all these knobs. I found these Raytheon knobs. I had this one on here. It's been on there for years. I found this somewhere. I don't think this one's a Raytheon knob, but it's the same style and the same, texture and everything as these other ones. So what I'm doing is, I got all these these new old stock Raytheon knobs, and I'm going to put these across here. And that 5 meg pot is going to go there. Adjust the screen. If it'll work, it's going to go there. I'm just going to have I'll probably just take a piece of coax and just put like an RCA jack down there on the rack for the exciter. I'll just run a cable down and I'll plug it from the back of the RF deck down to the back of the, or down on the rack where the connection is for the exciter to the screen. So that's what I'm going to do. It's going to go there, and I'm going to have matching knobs all the way across. And I've got these 2 matching knobs here. But what I also found is, and it also matches, these are the knobs, the same texture, same style knobs that are, on the exciter, see? So it's all the same thing. But I did find, what I was talking about the last time is, in one of my temp videos, is I need to make these knobs match too eventually. And I'm thinking, where can I find something that's got the same texture, same shape? Well, guess what? I found some more Raytheon knobs. Look at these. Look at these. So I realized what I can do. If you've ever taken, these are knobs off of a Johnson Desk kilowatt matchbox, and I've also got another set of these, so I should probably grab 2 more of these knobs before it's too late. But I looked at this. If you look at the back, you got 3 screws that holds the Bakelite part on to this part here, the scale. I can just remove those screws and pull it off. And what I realized I can do is I can drill holes in this panel, and you maybe use a little short standoffs and mount these guys flush to the panel. Then I can just have this part that spins, with the arrow, see, the white arrow. This part will be fixed, but this part will turn, and these knobs will match these other ones. So I'm like, hey, I think I figured it out. And I measured these before I ordered them, and guess what? They look like they're the exact same width. The flange is the exact same size, so that's perfect. So that looks like that's going to be the solution. So I get a set of matching knobs on this thing, and I should get 2 more of those for the other 2 knobs I have for the antenna coupler. So anyway, that's where I am on this, and it's coming to life, closer and closer. It's already the 1st of September. It's taken me so long to do that RF exciter because it's been so hot in the garage. And by the way, it's going to be 105 or 106 degrees here again this week, and oh my God, the heat wave's coming back again. Hope they don't shut we did lose power for about 2 hours one night about 3 weeks ago, but that was the first time it happened this summer. Hopefully it won't happen again, but it might. The fires are starting to calm down now, but if it gets hot again here this weekend like it will, we might have another couple fires emerge somewhere around this part of California. You never know. So that's it for now. Till the next time. But when I do the next video, this is going to be what, part 17 now, I think. I think this is going to be the new part 17. So I'll replace all those temp videos with this one. So till the next time, this is W5HRO.